Coming up on the premiere episode of the Change Mode Show, we talk about version control, space-time disasters.
That was really... No, keep going. That was good.
I think you were on the right track until you started laughing.
But I meant to say the other one, then I said the space-time disasters first. Just fine. I should have just rolled with it. All right, are we still good?
Yes, go for it.
Coming up on the premiere episode of the Change Mode Show, we talk about version control, space-time disasters, and the venerable air quotes. You're not going to want to miss this one. Stay tuned.
Brilliant.
This is the Change Mode Show, episode number 1, recorded April 13th, 2014. Version control, in air quotes. Welcome to the Change Mode Show, episode number 1. This is the show for everything between Hello World and high-frequency trading. My name is Dan Miller, and with me is...
Colby Ramadou.
Across the great American continent. So there's approximately 200 milliseconds of latency between us, but we'll make it work. Colby's internet may or may not be broadcast over microwave satellite dishes bouncing around San Francisco, which makes for an incredibly reliable connection with no drop packets or bandwidth issues at all. So with that being said, the first thing we're going to go into is who are we? So I guess I'll start. My name is Dan Miller. I have been programming professionally for less than a year now, or programming full-time professionally for less than a year now. I work at this place called Etsy.com. We are the world's marketplace for handmade and vintage goods. It's a lot of fun. It's a great place to work, and I've learned a lot since I graduated from Marist College a little less than a year ago, and that's why I'm here. That's who I am. Colby, who are you?
So I'm Lee. I went to Marist College with Dan. That's where we met. I live in San Francisco nowadays, and I work at a company called Facebook, which is the world's online marketplace for random pictures of your friends and listicles. I've also learned quite a bit since I graduated from school, and I've spent the last, I guess, 7 or 8 months now working full-time on a very large website that services many millions, if not billions of people, which comes with, a whole lot of challenges that weren't there when it was me and Dan staying up till 3 a.m, like writing Rubik's Cube solvers in Ruby. So it's been interesting. Should we mention like what we do for work?
Yeah, that's probably a good idea. So I am a programmer. I write code approximately maybe half of the day on a good day, probably. I'm on an infrastructure team. So broadly, in most companies, if the company is in the business of selling software, whether it's as a service or as an app or in a box, which is crazy, there's infrastructure teams and product teams. Product teams make like the stuff that you use. So, for example, there is a product team at Etsy that's working on the shop homepage, and they make the homepage for the shops. Infrastructure teams are, broadly speaking, make tools for the product teams to use. So my team specifically, we make the internal ORM, Object Relational Mapper library. We make wrappers around Memcache, a bunch of libraries. We do a lot of actual almost sysadmin work with monitoring computers, setting up monitoring, figuring out what metrics we care about on which servers, looking at the end-to-end performance of the back end and stuff. So broadly speaking, that's what I work on. It's one of the reasons it's an interesting job is because it is so broad, and I can be writing a compiler one day and trying to figure out exactly how long it takes Etsy to load in Singapore the next day. So it's interesting. Colby, how about you?
Cool. So I've actually had two different jobs since I worked at Facebook. After I started, I joined the mobile web product infrastructure team, which is a weird thing at Facebook because we're a much larger organization than Etsy. And the product infrastructure teams built like the tools, the front end tools that actual product teams use to build products. So for example, at Facebook, if you want to render an image, there's like this one component, or well, there's more than one, but there are a set of standard components that you can use to easily render an image. So the product infrastructure teams are responsible for maintaining things like that. So basically, our job is to help the like full product teams build stuff faster. And I when I started at Facebook, I joined the mobile web team. So I work on the M site in both for touch phones and for like more basic feature phones. And in January, there was some company reorganizing, so I ended up switching teams to the Composer team. And the Composer is basically the text box that you write statuses in on Facebook. But I still work on mobile web. I just work on a product team now.
Cool. So this show, we said in the beginning that, or I said, Colby really had no opinion. He didn't have any time to input, but we said that it's from like between Hello World and high frequency trading, which was just my attempt at automatopoeia for, that's not the right word. What was it? Alliteration. Yeah. My attempt at alliteration for what we do, but in more words, why, when you leave school, we had lots of knowledge about trees and compilers and how computers are built with logic gates, but we had less knowledge about how do you write programs with a lot of people, how do you get work done productively. These are all things where in school it doesn't matter as much. You might be working with maybe 3 other people on a large project. You might have some code to write, but chances are you're not working with thousands of other people, and you're also probably not working on millions of lines of code at any given time. So in this show, we're trying to address those problems, those weird things that they really shouldn't teach you in school because you don't have the opportunity to learn what it's like to work with 1,000 people at school, and you don't want to have to write a program for class that's millions of lines of code long. So we're just interested in kind of filling out our knowledge, spilling it out onto the internet, and helping other people learn that stuff. We can be found at coffeeandbeer.tv/CHMOD777. I'll plug that again at the end, but if you didn't catch it, coffeeandbeer.tv/CHMOD777. So, Colby, are you ready to get into the first topic, the first ever topic of this show?
I'm really excited.
Okay, cool. So topic number 1, version control. Colby, what is version control?
So version control is a tool for basically managing, well, it's a programmery solution to having multiple people edit the same set of files at the same time. Does that make sense?
I think so. So it's like Dropbox, right?
Yeah, exactly. Except more complicated. And like
okay.
pretty much
that
only
as a
for
troll
text
response, but I'm interested to see where you'll go with it.
What's that?
I meant that as a troll response, but go on. So it's like
Well,
Dropbox, but more complicated.
right. So Dropbox is like version control for laymen, right? So on Dropbox, you set up a folder which Dropbox watches, and you can add files for the folder, and Dropbox syncs the files up to the cloud. I just did air quotes, even though you can't see me.
We'll add them in post.
Okay, good. And and you can use Dropbox to share with other people. So you can, share a folder. Like I can share a folder with Dan, and when I added a file or changed a file, those changes would be uploaded into the cloud, and Dan could download him onto the computer. And version control works much the same way, except it's like you have much finer control over how exactly you change things and when they're synced with your central repository of changes.
So what problem is version control trying to solve? Like, is it the same problem that Dropbox is solving, where you sync files between people?
Well, I think that's part of the problem, right? Because when you have 10 or 20 or 1,000 or 5,000 engineers all working on the same set of files at the same time, like they need to share those files, and all those engineers need to know about all the other engineers' changes as soon as possible. Otherwise, everyone's going to be breaking everyone else's shit, and we'll all be pissed off.
Yeah. So apparently I just looked up the air quotes dictionary definition of version control, and it is the task of keeping a software system consisting of many versions and configurations well organized. Does that gel with your perception?
Yeah, it does. It does. I think, yeah, that makes a lot of sense.
So here's always how I've explained version control. If you've ever written a paper, and sometimes, especially in your later stages of your life when you're writing papers, also known as college, you have. It's not like in high school. At least for me in high school, I would sit down, I would read the prompt, and then I would just write the paper and I would print it out. In college, that's a little less feasible because the papers are so long and so much more complicated that sometimes, and if you have revision cycles with a professor or something like that, it can be difficult to know. So say you sit down, you write the paper, and you kind of take the prompt and you go off in a direction, and then you bring that over to your friend maybe and say, hey, what do you think about this? And they're like, well, I didn't really think that this diversion you took was worth your time. I think you should just cut it out. And so you do. You cut it out, Control S, move on, and then you write some more, and then you bring it to your professor maybe for the first round of editing, and then he says, I really think you should have gone into more detail about this thing. And you're like, well, I just deleted that thing. Now I have to rewrite it? And so you do. And then from that point on, what you do is every time you save it, instead of saving it, you actually save mypaper1.doc, mypaper2.doc, mypaperfinal.doc, mypaperfinal2.doc, and you do it that way, which works pretty well for papers. But if you were working on multiple papers, or if you were working on one paper with multiple people, and then you said, okay, person A, you need to write this part, person B is going to write this part, and person C is going to write this part, and then we'll just combine it all together at the end. That's where I think version control gets more complicated. That's also where this metaphor breaks down, so let's leave it. So there's a couple different... so version control is basically this idea where you can keep track of versions of a thing over time. and you started to hint at how that could also be useful for syncing work with other people. But I think that that's a side effect of the primary motivation, because version control is still useful if you're only working on with yourself, right?
That's true. Yeah.
So we can get into later how it helps with other people, or maybe we can get into it now. Or do you think we should cover some more terminology first?
I don't know. I mean, I guess. I mean, I feel like so. I think most programmery types have heard of version control, right? Like maybe.
I don't think so.
All right.
I mean, I think most programmery types that work in a professional programming setting perhaps have heard of version control. But
Fair enough.
unless we had brought it upon ourselves to learn version control in school, we would never have had to use it, right?
That's true. I suppose I probably the first time I used it was because you were like, "Yo, we should use this,"
Yeah.
and we did. All right. I'm
Okay.
convinced.
Cool.
We need to talk more about this.
Okay, so we've got this thing. It keeps track of versions, and if you're working with multiple people, that model works really well because you can kind of submit changes to one another instead of if you were collaboratively working on a paper with just one other person, let's say. What you might do is you might write some stuff on the paper and then email it to the other person. They might change some stuff, write some more stuff, delete other things, and send it back. Unfortunately, while the other person is doing all that work, you can't do anything because you have no idea what they could do. They could do any one of those actions, add, change, delete, and they could do it. They could change everything, or they could add only one line. So while they're doing that, you're just like, well, I'm not going to do anything because I don't know. I could be operating under false assumptions. With programming, it's a little less volatile, but the same problems exist. So if you're writing a program and say you're writing this Rubik's Cube solver, it's a good example. If you wanted to do that without version control, you'd either both have to sit down in the room and write it together all the time, or you'd have to say, okay, I'm going to write this and you're going to write that, and then at the end we'll combine it together, but then hopefully you don't have to revise each other's other things because then you get into this process of emailing files back and forth. So, Colby, how does version control solve that problem? What is the mechanism by which we can work with changes independently of one another and have it all just work out in the end?
So, I think what you're talking about is merging, correct?
Yeah.
Yes.
Yeah.
So basically the way it works is when one of the programmers working on said version controlled project finishes a discrete hopefully atomic chunk of changes to your program, you'll record these changes in the version control system in a unit which is generally called a commit, I believe, in most systems.
I think so, yeah.
Yeah. So you commit your changes, and at that point, the version control system knows about them, and then you sync them with like the canonical source of version control that is shared between you and your partner or partners in crime. And at that point, it could be the case that the person you're working with has already made a change to the file, which changes the same part, line, or function, or variables that you've just changed. And the version control system will recognize that for you, and it will let you know, and it will notify you of what is generally referred to as a conflict. So at that point, it'll show you, like, generally in line of the file you change. It'll show you, here's what you did, and here's what this other dude did, and you,
Or
it's you.
or dudette.
Yes, dudette. I apologize. um, so here's what the two of you did, and now it's your responsibility to figure out, like, how to reconcile those two changes to make them work properly.
Right, and so the way it reconciles changes is actually pretty intuitive, because if you think about it, if in the emailing situation, I guess a fundamental tool that makes this way easier is the venerable diff. So you may have heard of this before, but diff is, I guess, stands for difference. And diff is a tool. There are visual tools and there are command line tools that takes two files and shows you what's different between them. And it does this by putting a minus sign on a line that was deleted from the left file and a plus sign on a line that was added. So if you're merging two things, it's really simple to merge additions because two additions do not conflict ever. They could be almost the exact same thing, and that's a problem that you're probably going to want to solve. But in terms of taking those two working pieces of program and adding them together, they will both always still work at the end, both in the way that you intended them. Minus signs are a little more tricky because that can change anything. So if two people delete different sections of a program, that's okay. If they delete the same section in different ways, that's when it gets really tough. And that's when you'll see a merge conflict. And I think most version control systems always defer to the programmer in those situations. So what they basically end up doing is showing you the diff and then saying, resolve this how only a human could know how to resolve it.
Right, because version control systems are language agnostic. So it's not like your version control system doesn't know Ruby or it doesn't know JavaScript. It can't, like, it can't make assumptions about what you were thinking. Like, at the end of the day, it's a pretty dumb tool. So it'll do its best, but it will defer to you because it recognizes its own ignorance, I guess.
That's something we could all learn a little bit from, I think.
Yes.
Cool. So we've got version control. It can keep track of versions, and it can merge things between two different versions, potentially. But what is the actual mechanism by which you would send these changes? Is it email? This is a trick question.
No, it's not email.
It can be email.
I guess
Did you know, Colby, that Git has a send email command?
I did.
Yes, Git send email. So you can take something in this version control system and send the change as an email to someone else, at which point they can merge it in themselves. So I do believe that most version control systems, I bet that's not true. So is this a good opportunity to get into what different kinds of version control systems there are?
Probably, because I feel like the mechanism for sharing is probably different. So I have a question. Could is that email feature in Git a sort of throwback to how well, all right. So first brief history lesson, Git was written by Linus Torvalds to help him manage the Linux kernel.
Because he hadn't written enough code that changed the world yet at that point in his life. So
so changing the world again. But if you've ever heard him talk about it, he'll kind of wax poetic about the old days when contributors to the Linux kernel would submit patches I just did air quotes again. God.
Okay.
They submit patches over email to him or to like some forum, of people responsible for merging, for maintaining the kernel.
Yeah.
And at some point, it just got so big, and there were so many patches, like just no one could manage it anymore. So that's why he wrote this system. But I would imagine that send via email thing is sort of a throwback to the way they originally did it.
Right. And originally, Git, or rather Linus, used a different version control system for the Linux kernel. And I don't remember what it was, but it was a BitLocker, I think. Nope,
Oh, I've heard of it
BitKeeper,
before.
something like that. Not BitLocker, that's a Microsoft thing. BitKeeper, which is proprietary. It costs money, but he was paying for it. Then he decided it totally sucked and he was going to write his own. So that was the origin, or that is the origin story of Git. But before we get too far into the specifics of any particular one, I would point out that there are two different kinds of version control. And there might be more. I've only heard of two. The two
There
kinds...
are two popular version control.
Yeah, and I think that due to the nature of these words, everything would have to fall into one or the other. But the two different kinds of version control are centralized version control and distributed version control. Centralized is really easy to understand. And in fact, if you think about it, centralized is still kind of the most widely used. So centralized is where everyone submits all of their changes into one central location, one server, basically. And that server is responsible for resolving differences, and it could send the change back, reject it, and say, well, this conflicts with this other change, so you need to pull down the most recent changes and fix it. That's centralized version control. SVN is centralized version control, correct?
Yes.
Is Perforce centralized version control?
That I'm not sure. I think so. Yeah. So I'm looking at the Wikipedia page, which
Perforce is centralized according to Stack
Yes.
Overflow. Yeah. So Perforce. What's the other one? SVN and Subversion is SVN, right? I could be wrong about that.
Yeah.
Yeah.
Subversion is SVN.
Yeah, CVS is the other one, which is really old that no one uses anymore, and it's called and it stands for Concurrent Versioning System. So, if my understanding of the history of this is correct, CVS was kind of the big standard for the early open source stuff. I'm sure Microsoft also has a version control system, but CVS was kind of the big one, and it's not the drugstore. Team Foundation version control is another one that Microsoft made. An earlier Microsoft one is Visual Source Safe. So CVS was the big one, and then everyone was like, this is totally garbage, and we need a better one. So then they made Subversion, and then Subversion kind of got subverted by this I don't know if it was new, but this other way of doing version control, which is called distributed version control. And Colby, can you explain what distributed version control is and how it's different than centralized version control?
I can try.
Okay, you should try.
So I think I'll talk for a second about what exactly like centralized version control is. So in centralized version control, there are two types of actors, right, in this process. So you have a server, which is the like canonical reference of all data. Like that is where the changes are stored. That is where you push the changes. If you want to like start working on the project, that's where you get your project from. and then there are clients which subscribe to these changes and the canonical state of the server. So your client, your Subversion client, is entirely dependent upon the server. If you want to commit, you commit to the server.
What's a commit?
So we did briefly mention this earlier, correct?
I don't think we associated the word commit to it, though.
Oh.
So, yeah.
Well, in any case, a commit is like a record of changes. So it's like an atomic unit that is like, you know, well, yeah, it's a record of what you added, what you changed, and what you deleted, basically.
Yeah. Very similar to a diff, air quotes.
Right. Right. So yeah, that's the thing to remember. Is basically centralized version control. If you don't have access to the central repository, you cannot commit.
Right.
So you cannot record your changes and share them with other people. The distributed model is a little different in that type of there's an actor. There's no like client who.
I think we might have lost Colby.
There's no.
Oh, he's back. The microwaves are doing great. And
Am I back?
I think so. Maybe.
Okay. All right. I'll continue
Talk more
talking.
slowly so that the internet doesn't lose track of you. I'm just kidding.
Oh.
That's how that works.
I'm outrunning the pipes or something.
Yeah. Yeah.
Too fast. Over the speed limit.
It is the information superhighway after all.
Yes, but the speed limit is 65. It's not the information super autobahn. So
that's Korea. All right. Internet jokes over.
Anyways,
distributed version control.
Yeah. So in the distributed model, there's only one type of actor. So effectively, everyone who's working on a distributed version controlled project has a local version of the entire repository. So if you want to make
what's a repository?
So a repository is like, you could think of it like a project. It's like the top level unit for
yeah. It's your program. It's your book,
right.
Which could be a collection of documents or a collection of like Java classes or whatever it is.
Right. It's basically the top level folder in your file system hierarchy of this project.
Yep.
So as I was saying, in a distributed model, each client, anyone working on a project has full access to their version of that project. They can make commits. They can remove anything they want. So the main difference is that, like, the easiest difference to see is that you can work offline, right? You don't need to be connected to the server to do your work, which is cool because, I mean, it becomes much more useful on a personal level, like to be able to record your changes and work in this sandbox.
Yeah, because for instance, before distributed version control systems, you would have had to set up your SVN server that would exist on your local computer. Maybe it wouldn't, but either way, that's a lot of work.
Mm-hmm.
It wasn't just standalone.
Yes. So that's cool in and of itself. And so the question then becomes, how do you share your changes with other people? And basically what happens is you would have a server, or it could even be another person's version of this this version control repository. It could be anywhere, and that server or other client is like takes on the role of these I guess main version control server in a system like Subversion. In a way,
Well, it can.
It can, right?
So do you know how the modern Linux kernel development cycle occurs?
I don't.
So it's kind of like a ring network in network terms. So Linus is in the middle. He has the current like master version, stable version. He has the whatever the next one's going to be. I guess the beta version. And it's entirely distributed. So he has that on his computer. He hosts it online too, but it's on his computer. Now Linus has these lieutenants, I think they're actually called, that are responsible for different things. So there's a networking lieutenant and a graphics lieutenant and maybe even something like a webcam lieutenant. And these people are really good. In fact, Linus says they know better than he does what should be accepted into these subsystems. So, and then outside of those are other people like us. So if we had a change to the Linux kernel, say we changed a network driver or added one, we wouldn't send that email, and it is all email. We wouldn't send that email right to Linus. We would send it to the networking lieutenant. And then they would look at it, maybe have some back and forth with us over what the change is. They would apply it, that commit, to their repository. And then at some point, they would send another commit to Linus that would have our commits and other people's in it. At which point, Linus would review it. And then if he accepts it, then it would get accepted back into his repository. But Linus can also, because Linus is just another server, he can send commits to the other person if he has a change for the networking stuff. But because Linus, he doesn't think of himself as knowing entirely what what am I trying to say here? He doesn't pretend that he knows everything about networking. He's just Linus, he's just this incredible programmer who's sometimes an asshole, but he will also submit his changes to the networking guru to get reviewed before they get sent back to him. So it's almost like a social network of programmers, which we can get to next, of people just sending changes between them. There is no centralized repository. If Linus died in a tragic space shuttle accident, I think that would be the only fitting way for him to go. Then someone else could just immediately become the central spoke in this thing. It's not dependent on Linus at all. There are no passwords. There's none of this stuff. So that is how Linus built Git. That's how distributed version control systems are meant to work. But of course, you can make a distributed version control system behave very similarly to a centralized version control system. And probably the best example of this is GitHub, which I believe does bill itself as the social network for programmers. Is that true? Maybe not anymore.
I think
build software better together.
Coding, right?
Social coding, that's what they called it. But I don't see that on here anymore. Yeah, they got rid of that language.
Maybe they dropped it. It's not social. This is not for fun, Dan. This is serious.
Yeah. So GitHub is a service. GitHub is a website, github.com. You can have a GitHub profile. You have a GitHub profile picture. But GitHub is built around regular old Git, like you would install on your computer. GitHub is just another Git installation. It just happens to be an incredibly high volume one. So you can have repositories on GitHub and you can pull them down onto your computer, and then you can push changes back to GitHub. GitHub does cool, fancy things where it can show nice, fancy visual diffs of changes. Can you explain what a pull request is, Colby? Because that's probably like the I don't know, the lingua franca of certainly GitHub, if not all of open source programming these days. And then I will explain how that is imitated in the email, or not imitated, but how that actually came from the email standard of things.
We've come full circle nearly.
Mm-hmm. So yeah, now the distributed version control has become centralized, and that's why I said earlier. Still, most people use centralized version control because really GitHub is centralized. Because if it goes down, you're kind of screwed. Like you didn't keep a record of whose repository you wanted to push to. You depended on GitHub for that. So, but anyways, what is a pull request?
And I think also like the way most companies would use a version control system like Git is pretty centralized as well.
Yeah.
Anyways, pull requests. So consider GitHub. It's this magical collection of many thousands of Git repositories, some of which are as meaningless as my personal website.
Some even more so.
Yeah, some even more so. Some as meaningful as, for example, like Ruby on Rails or you know the Laravel PHP project or the React JavaScript library or jQuery even. I think all of those are hosted on GitHub. So these projects are open source, and what that means is that really anyone is free to submit changes or bug fixes or features to them. But the question becomes on GitHub, how do you do that?
Yeah.
So obviously you, like, as some random programmer who isn't like, you know, John Ressig and work on jQuery, you don't have direct access to the jQuery library, because if everyone could change it willy-nilly, that would
like
be
a Wikipedia if GitHub were Wikipedia, it would be pretty chaotic.
No one would get anything. Yeah. So on GitHub, what happens is I believe they call it forking. Mm-hmm. But you can go to the jQuery repository GitHub page and click the fork button, and what that does is that takes an exact copy of the jQuery GitHub repository, and it copies it and associates that with your account, and that copy of the repository you can change, and you can change willy-nilly and do whatever you want with it. So at that point, say you create this new wonderful feature that's going to change the internet for the better, and you think everyone should know about it and be able to use it. So you want to submit that back to jQuery. So what you would do is from your fork, air quotes again, of the jQuery repository, you would make your changes, you would commit them to your repository, and then you would submit what's called a pull request on GitHub to the main jQuery repository. So what a pull request is basically it notifies the maintainers of jQuery that you have like a set of changes that you think are worth including in the library. So it opens up this, I guess it's basically a conversation between you and the developers. So everyone, and it is entirely public on GitHub. So everyone can see, they can see the changes you made.
I can share my
them.
screen and you can
comment.
maybe look at one.
Cool.
If our wonderful producer can handle that. We'll have to see though, because we can't hear anything he's saying, and so we can just tell him to do things,
Dan,
And
go for it.
that was
Cool. I've never had a
unexpected.
producer before.
Yeah, it feels good.
Does this?
Then
Does it?
the real problem is I
Made a
have to
big.
remember how to do it. Share screen. Here we go. Of course. Oh, there we go. Skype is smart. Okay, so here's a pull request. Here's one that I wrote. This first tab here is called the conversation tab. This is just like what people have said about it. It's entirely useless in my opinion. The really cool thing is when you go to this files change tab, and here's the diff that we discussed earlier. Green is added with a plus sign next to it. Red is deleted with a minus sign next to it. So here's the change that I submitted. I added a bunch of code there. I deleted much less than I added, unfortunately. I wrote a lot of tests here. And of course, I have since. So the person that I submitted the pull request to, did make a lot of comments, and we can see them here. When he originally made them, though, he would have made them directly in line. So here, if I want to sign into my account, yes, please, GitHub. Da 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 da. Colby, you wanna? Oh boy, two-factor authentication. Well, anyways, take my word for it. You can click on the code and write a comment in line right beneath it, so you can have a discussion about it. So right there, we could have said, "I really don't think you should have deleted this line. Why did you delete it?" And then I could respond and say, "I deleted it because of this reason." Or I could respond by changing my commit and just adding it back, at which point that discussion would disappear back to the conversation tab. But yeah, that's what a pull request looks like. And I'll point out that this is pretty much exactly how pull requests worked in the email model. You would send your change, this, to someone via email. They would get it, they would make some comments, some changes, and you'd send it back and forth. This just makes it way easier, but you are dependent on GitHub existing at this point, so the email is a little more robust.
Indeed.
And now I will stop sharing my screen. Cool. Is there anything else to talk about with version control? I mean, there's so much to talk about.
I mean, we could talk about, like, I guess how our companies use version control.
Right. Right. Yep. So there's especially in Git land, there is a quintessential debate. I don't know if it's all that, or if it's just the people I surround myself with, but something we haven't really addressed is this concept of branching. So here's where I think the concept of branching came from, and I could be wrong, but here's where branching is useful. So the Linux kernel. The Linux kernel maintains several versions at any given time. So I don't think this is true anymore, but I think at one point, specifically, there was the 2.6.x version, and then there's the 3.x version. 2.6, of course, was older, but they were still providing security updates for it. 3 was newer, and they were doing a lot of active development on it. Oftentimes, though, if there's a bug in some code, say, for example, you forget to check the length of a string and allow anyone to request any amount of information from a library, OpenSSL, and that change exists across multiple versions, you have to apply the change not only to the 3.0 version, but also the 2.6 one, and then re-release new versions of both of those. So that's where branching is really cool. So branching allows you to have a separate, since we are all computer science-ish majors here, kind of, you can think of it as a tree. So branching allows you to have a branch on your tree that goes off and has different commits, but then you can also merge trees together, just like you can merge two repositories together. Or a change, you can merge a change, a commit into a repository. You can merge two branches together. You can apply a commit to different branches individually. And that's where I believe branching, that's why I believe branching was invented, or how it was conceived of. Now, a lot of us write software for the internet, this crazy new thing. Colby, when was the last time you bought software and it came in a box?
I think I bought in. It was either freshman or sophomore year of high school. I'm
I thought
sorry,
you were going
not
to say college.
college. It was
Oh,
college.
wow, really?
It might have been the very tail end of high school, but I was at that point. I was not yet a computer science major, and I was in interactive video, and I was really into video editing. And I asked for Christmas for a copy of Final Cut Express from Apple, and that was pre-Mac App Store days, and that came in a box. And I still have that box somewhere. But yes, it was like freshman year of college, but it's been a while. I mean, that was like 4 years ago, 5 years ago almost.
Right. So shipped software has the same phenomena where Apple shipped a version of Final Cut and it came on a disc. That was it. It was literally burned into that CD. It could not be changed. So they had to keep track of what code was on that disk, and then if there are, again, massive security updates that they had to get you, they had to know what version of the software was on that disk and then apply the patch from the new version that they haven't shipped yet onto that one. So that's another use of branching. But Colby and I, and most people, I believe, programmers, no longer write shipped software, as it's called. Whether you work in like an insurance company writing internal tools or on a website, you're no longer shipping your software in a box to the customer anymore. It's delivered over the internet. For something like Final Cut now, you can deliver updates pretty seamlessly. It's still not, you might deliver an update once a month, maybe once a week. That'd be kind of annoying though. With websites, we deliver updates maybe hundreds of times a day because it's completely transparent or opaque, depending on how you fall on how those words are used, to the user. They don't know that it's happening. They don't care. Whereas with updating Final Cut, you have to download the gigabytes of data, and it's a total mess. So a lot of people now say that if you're not writing shipped software, then branching is more trouble than it's worth, especially if you're working with thousands of people. So if Colby and I are working in a company and I branch off, I'm going to make the new Facebook dislike button that everyone wants. And I have to imagine that that would not be an easy change. So I'm going to make a branch, and that kind of freezes in time Facebook. And then I just go off and I make the image and I add some stuff to the database and I'm doing all this stuff. Meanwhile, Facebook is barreling past me at like 10,000 miles an hour, and so many things are changing. But I'm off in my happy little world with my frozen Facebook, adding my new feature. Probably takes me a couple months, to be honest. And then I'm like, okay, great. I've got this dislike button. It's on all the places it needs to be. It works. Let me just merge this back in. And then you find out that there have been, a couple 100,000 commits since you branched, and the entire interfaces of other things that you were using could have changed completely, and now you're screwed. Whereas if you had instead made small changes onto master, the main branch, every time, so like I'm going to add the dislike button to a wall post. I'm going to add the dislike button to a note, or just one at a time. Slowly do it. Maybe wrap it in an if statement so that people don't see it yet, but just slowly get it out there one at a time. But without branching, you'd be better off. And that's actually called branching in code. Colby, do you feel strongly about branching at all?
So,
or how does that's how Etsy does it. So Etsy does what we call continuous deployment which is this thing where we commit 60 times a day, and it goes live to the users 60 times a day. Well, we commit way more than that, but it goes live to the users about 60 times a day. So that works for us. What does
Cool.
Facebook do?
So I think at this point in its history, Facebook is in a little different position as we have several thousand engineers. So I don't think something like continuous deployment would work for us. So we have so that being said, we do deploy the site multiple times a day. So Facebook is updated twice a day, every weekday. So there's a push in the morning and there's a push in the afternoon. In addition, there is a weekly push on Tuesdays, in which most changes go out. So an interesting tidbit about Facebook's version control. If you're more interested in this, there are like extensive talks about the release stuff and like how our system works online. There's a famous and or somewhat infamous guy named Chuck Rossi who is like the champion of our release engineering team. Very smart and a little scary, because if you break stuff, he's the one that comes and finds you. But yeah, so at Facebook, we do use, well, for many years we used Git, and we've recently started using Mercurial, which works very much like Git, and the differences are minor.
Mercurial.
Yes, the differences are minor and probably not worth getting into right now. But Facebook's central repository of code, like the central, we call it trunk, which comes from the fact that it is a Subversion repository, and in Subversion, trunk is like the main server branch of like the code.
The trunk of the tree.
Right, exactly.
Yep.
So what we do is we have a Git or Mercurial like repository locally where we make all our changes and record them, and then that branch mirrors trunk. So when we pull in new code that everyone has made since the last time we updated, it goes to Subversion, checks it out, and inserts that into our Mercurial repository. So I would imagine I think our system probably works a lot like yours does, because when we commit one, like when we actually commit changes, we squash all our changes that we made into one commit that is pushed to the central Subversion repository. So branches.
That's not what we do, but go on.
Okay.
But just for clarity.
Okay. Yes. All right. Good to know. Oh, Sean's distracting me.
Yeah.
What a guy. What a nag.
Sorry.
So we use branches is purely as a utility thing locally. So there aren't branches of Facebook that everyone like shares, that multiple people share. There's no like server with a bunch of branches on it, right? There is one branch, and that is trunk. But locally, I use branches every day, because so consider I have many things to do. Like right now I probably have like 20 tasks to my name. And sometimes I do a bunch of work on one task, and then I need to, for example, wait for, my manager or our project managers to make a decision about something before I can move forward. So my choice is either sit around until, that decision gets made, or I can start working on something else. So that's what I use branches for, is for like keeping my work on separate tasks isolated from one another.
That makes sense. I should probably be better about that.
Yeah, it's like it can get out of hand, but it's really useful. And so once I'm finished with a task, I take all the commits in my branch and I use in Mercurial it's called hist edit, but like history edit. I just did air quotes again.
Yep. Yep.
And in Git, I believe it's called an interactive rebase.
Yep.
But what you can do is you can take a bunch of smaller commits and squish them all into one commit. And then once I've done that, I'll put that change up for code review, which is something we will talk about in a later episode, but is heavily dependent on version control.
Yeah.
And then once everyone's like come to a consensus that this is a good idea, that commit is committed to the central like trunk. And yeah, and then the next week it'll go out on Tuesday to the rest of Facebook. So
cool.
Yeah, so I use like the TLDR on that is that like I use branches for handling tasks. So I don't want to mix code from like, you know, changing the font sizes with code that's, you know, adding a new tagging feature or something like that, because, you know, what happens if you accidentally commit some code that wasn't ready?
Right.
So yeah, that's my story.
That's totally never happened to me before.
I've certainly done that before.
Yeah, I should. So that's one of the beauties of distributed version control is your branch does not have to exist on anyone else's repository.
Right. You're like it can be a personal thing. It's like just between you and Git.
Right. Okay. I think that's all we have time for on version control right now. We did not discuss this beforehand, but should we do programming related picks? Do you have anything you're dying to talk about? I know in the past there's been things that I've always wanted to tell people about. Of course, as I'm saying this right now, nothing's coming up, but if you bought me time, I might be able to think of something.
All right, let me think hard and fast.
Okay.
All right, so well, again, this is sort of a shameless plug, but
okay.
So I'm a front end engineer at Facebook. So basically, my job is to be like really fucking good at JavaScript and CSS, which is great because like I love JavaScript and CSS. And so a couple months ago, Facebook open sourced a new JavaScript library for doing, I guess, UIs in interactive UIs in JavaScript called React.js. And it is I think it's a pretty unique approach to how to do it, and I think it's a really awesome approach. And the cool thing about it is that it's pretty agnostic as far like all it does is render your views. If you can use anything you want for data fetching, it's really easy to integrate into something like Backbone, which has you know a really solid data model and like the controller setup, but the view rendering is a little iffy. So it's really cool to plug into something like that. It does come with a certain amount of learning curve, but like once you wrap your head around what's going on, it's really awesome, and it really encourages reusable JavaScript code, which is something that's really hard to do, especially with view rendering. So if you're into that sort of thing, check it out. That's my pick.
Cool. React. What's the website for React?
I think it's reactjs.org.
.org. It's not .kitchen?
It's not .com. It's
not
that
.com. Works.
or facebook.github.io/react will get you there.
Cool. So I guess in keeping with the theme, I've been playing around with Facebook's hack language, and that's available at hacklang.org. Hack is basically PHP with some cool things, mostly typing, So you get type annotations, and by way of that, you get generics. The other major thing it adds is collections, which are, if you know the Java collection framework, you get vectors and sets and maps and things like that.
It's certainly much less extensive than the Java collections.
Right, yeah. It's possible to actually know the hack collections, whereas, yeah. But almost more importantly, it adds optional commas in your function signature, which is amazing. So if you know PHP, PHP has optional commas in array syntax where the first element of your list can have a comma, and the last element of your list can have a comma, and that's fine. Whereas normally, if you have a list of multiple things, everything except the last one can have a comma in most languages. So I've appreciated that an awful lot. It almost feels as good as when PHP added the short array syntax with the 2 brackets instead of typing out array open parentheses. So I've been really enjoying hacklang.org. It's a fun time to get into it and play around with some of the stuff that it can do. So hacklang.org is me.
So Dan, I have a question. Quick question. Why
Sure.
why are an optional last comma? Why is that a good thing for you?
Okay, so it's one of the many inconsistencies in PHP. So PHP has a lot of inconsistencies.
I see.
The needle haystack crap with any function that has the either needle or haystack in it. This one bothers me the most, though, for some reason. Oftentimes, I am writing a function signature that takes a lot of parameters, and usually when you do that, you put new lines in. And I'm used to doing that with arrays where I just always put a comma at the end, because then if I have to add another thing, I don't have to worry about if there's a comma before it. And so I started doing that just recently, actually, with function signatures. And I would always have to go back and change it because it's a fatal syntax error.
I see.
I don't know. It was just a nice thing.
Yeah. So we actually do the same thing at work, but like maybe this is the reason it's supported in Hack. I don't know, but from a version control related and like practical sense, when you have a function signature that is like the params are on multiple lines, like you mentioned,
Right.
when you add a new param, if you have to add a comma to the previous param, that will change the blame. So the when you're in Git, when you there's a command called blame, which will go through each line of a file and tell you the last person who changed it. And if you have to add a comma to the last line, that line will blame to you, even though you didn't actually add that parameter.
That's a really good point. That relates to my point when we have our episode about coding style, where we talk about the C style versus the whatever style of brackets on functions. Yeah. I think it will relate. It's to put a bookmark in that, to be continued. So This has been episode number 1, the premiere of Change Mode, the Change Mode Show. You can find us at coffeeandbeer.tv/CHMOD777. Twitters and other things to be announced. Perhaps our illustrious producer will add them in at the end. But
they are on their way. But
their way.
That will all be linked to at the website, YouTube, iTunes, RSS. It'll all be there. coffeeandbeer.tv/CHMOD777.
And check out all the other fantastic Coffee and Beer TV programming, which I think will also be soon to be announced. But if you're bored, like a lazy Sunday evening, you've got a glass of scotch in your hand, you just want to watch some great internet TV, go to coffeeandbeer.tv. I guarantee you'll have a good time. That's all we have for today. Thanks for listening, and we'll see you next week.
Woo! Later.
This show is brewed fresh weekly by the Coffee and Beer Podcast Network. Get all our shows at our website, coffeeandbeer.tv.